Yesterday we had calculated the load on the slab, loads on the flight, as well as the loads on the landing and the mid landing. Now today we are going to, yes, yesterday's part everyone understood. Anybody is having any queries up till load, calculation of loading for flight as well as for landing and mid landing? Now we need to solve the next step. So after calculation of the loading for flight as well as for the landing and mid landing, we need to calculate the shear force and bending moment. So as you can
हम कभी शुरू किया?
just now, yes. From next lecture onwards, please join on time. जितना आप जल्दी ज्वाइन करोगे और जितना फास्ट आप लोग सॉल्व करोगे उतना ही ज्यादा टाइम हमें मिलेगा, so that we can take number of problems. We can take more problems on same topic. So please join on time. So yesterday we had solved we had done the calculations for the flight as well as for landing and mid landing. Now proceeding for the step number 4, that is we need to calculate the shear force and bending moment. As you can see over here, यहाँ पे हमने क्या किया है, हमने we had drawn one beam and on entire beam the UDL is acting over here, and you can see this 19.53, this is nothing but the load on the flight that you had calculated. See the load on the flight, you had calculated it as 19.53, and the load for the landing and mid landing is 14.5 kilonewton per meter, and the total distance going distance is 2.75 for the flight. एंड आपने एल इफेक्टिव देखो कितना कैलकुलेट किया था, एल इफेक्टिव इज योर 4700, दैट इज 4.7. तो 4.7 में से अगर इफ यू डिडक्ट 2.75, सो डिवाइडेड 4.7 minus 2.75, that will be 1.95.
मैम क्या आवाज ब्रेक हो रही है?
The network is full. Now my voice is clear.
कभी कभी अच्छे से आ रही है, कभी कभी एकदम ब्रेक हो रही है.
Okay. So L effective is total L effective length we are going to consider for calculation of shear force and bending moment. So 4.7 is the entire length of the beam. So 4.7 minus this going distance, that is 2.75, आपको मिल रहा है 1.95. 1.95 is the total distance for landing and mid landing. But as you are having here, यहाँ पे भी आपके पास landing है, यहाँ पे भी आपके पास landing है. So 1.95 divided by 2, तो आपको मिलता है 0.975 and 0.975. तो ये यहाँ से लेके यहाँ तक का डिस्टेंस इज 0.975, and this one is your total flight. So this distance will be 2.75, and again this is your landing and mid landing. So again this distance will be 0.975. So now for this particular beam you need to calculate shear force and bending moment. Yes, understood? इसमें किसी को कुछ डाउट, ये लोडिंग कैसे आया या फिर ये डिस्टेंस कैसे आया?
मैम वो 2.75 ये है ना, गोइंग है ना?
Yes, going distance. Yes.
और फिर उसको माइनस 1 पॉइंट किससे किया?
उसको माइनस 4.7 से किया, दैट इज नथिंग बट द एल इफेक्टिव. इफेक्टिव लेंथ में से हमने 2.75 डिडक्ट किया, तो आपको 1.9 उसको
मैम 4.75 है ना इफेक्टिव लेंथ?
4.4700 millimeter है. So convert it in meter, that will be 4.7. So 4.7 minus 2.75, you are going to get 1.95, and 1.95 divided by 2 is 0.975 and 0.975. That is the length for the landing and mid landing. Now understood? So now calculate the shear force
Yes.
bending moment for this particular beam. Draw this diagram.
इसका कैलकुलेशन का है?
बताती हूँ. Shear force bending moment calculation you should know now. You are in 8th semester. पहले ये सिर्फ जस्ट बीम ड्रॉ करो, देन आई विल लेट यू नो shear force bending moment calculations. Just draw this beam first of all. You have completed this beam. Now you need to calculate RA and RB. So how you will calculate RA and RB? Take moment about point A will be equals to 0. So see, I think everyone is having the diagram for the beam. So when you are going to take moment about point A, moment about point A लोगे तो सबसे पहले क्या आएगा? This RB into this total distance. So RB into total distance, that is 4.7. So as it is anti-clockwise, so minus RB into 4.7. Then this 14.5 load, 14.5 is nothing but the UDL. So W into L by 2. So 14.5 into 0.975 into 0.975 divided by 2 plus this distance. That is this 2.75 plus 0.975. उसके बाद में आप कौन सा लोगे? ये 19.53 का लोड लोगे. So 19.53 into 2.75 into 2.75 divided by 2 plus this distance, that is plus 0.975. Then again you are going to consider this load, that is 14.5 into 0.975 into 0.975 divided by 2. So in this way you will get the value for the RB. Here there is not MB, here there should be RB. So do this correction, and if any query in this you can ask. So calculate RB. See, you are getting 40.74 only or not? This is very simple shear force and bending moment calculations. I think everyone understood this one. Yes, everyone got the value, that is 40.74. See, everyone is getting or not? Yes, everyone got the answer.
Yes, ma'am.
Okay. So as the beam is symmetrical, the RA will be also same and RB will be also same, as well as the here also RC and RD will be same. So this is your shear force diagram for this particular beam. So see, RC and RDB 26.81 आ रहा है या नहीं है? After completing shear force diagram, let me know so that we can proceed further. If anybody doesn't know how to calculate shear force diagram, you can let me know. Okay, done with the SFD. Okay. Now you need to calculate the distance x. To calculate the maximum bending moment, you need to calculate x. So calculate x, consider properties of similar triangle and calculate the value of x. The value of x is coming out to be 2.35. X is 2.35. Consider properties of similar triangle and calculate the distance x. The value of x is 2.35. Yes, everyone had got the value of x, that is 2.35. Or just note down the value of x, you can solve it later. Now see, the bending moment at this point, that is at point B, the bending moment at this point will be 0. So here the bending moment will be 0. And at this point, at point, this one, at this point, bending moment क्या आएगा? This load, that is 40.95 into this distance, that is 0.975 plus minus 40.95 into 0.975 plus 14.5 into 0.975 into 0.975 divided by 2. You are going to get the value, that is 33.03 kilonewton meter at bending moment at this particular point. Similarly, as this side is also same, also you are going to get the value as 33.03, and this maximum bending moment is 51.16 kilonewton meter. After completing these bending moment calculations, let me know so that we can proceed for the next step. अगर किसी को नहीं समझ आ रहा है कैसे करना है, so they can ask. Yes or no? All had completed up till here. Okay. Okay. Now we need to check for do the check for the flexure in the step number 5. So the step number 5 is our check for the flexure. So for this we need to consider the maximum bending moment. तो maximum bending moment की value हमें मिली थी 51.46 kilonewton meter. And here you have to consider the weight, that is 1000 mm. You have to assume the value of B as 1000 mm, so that you need to calculate the depth. So depth here calculated should be the less than the value that we had calculated in the step number 2. So mu is 51.46 kilonewton meter. B you are going to assume it as 1000 mm, and the formula to calculate D is under root of mu upon 0.138 FCK into B. So substitute the values of, convert it in mm. So multiplied by 10 raised to the power 6. FCK, the value of FCK is 20 as M20 grade is given to you, and the value of B that you have assumed it as 1000. तो आपको डी की वैल्यू मिलती है 136.54 mm, दैट इज लेस देन द डी दैट यू हैव कैलकुलेटेड अर्लियर। तो इसके पहले जो हमने डी कैलकुलेट किया था वो हमें मिला था 200 mm, सो दैट्स व्हाई आवर check for the flexure is safe. So do this step number 5th. Always remember here the value for movement, you have to take it as the maximum bending moment. Whatever the maximum bending moment you are going to get in the earlier step, उसमें की maximum value you have to consider for the flexure. After completing 5th step, let me know so that we can proceed further. I shared the score soft copy in your WhatsApp groups. We are done with the step number 5th. Everybody had got the same answer, that is 136.54 mm. Slightly increase your speed. Yes, completed. Mahfouz Tanveer completed.
Yes, yes, ma'am.
Okay. What about others? Everyone completed. Should I proceed? Okay. So we need to calculate now the reinforcement. So in step number 6, you need to calculate for the main reinforcement. You do need to calculate the AST required for the main reinforcement. So first of all, the formula to calculate AST required, that is the maximum required area, that is 0.5 into FCK into B into D upon Fy into 1 minus under root of 1 minus 4.6 mu upon BD square FCK. Here also you have to assume the value of B as 1000 only. So the value for FCK is 20 as the grade is 20 and the value of Fy is 415. as the grade of the steel given to you is 415. Then B की value आपको दी है 1000, D 200, then 1 minus under root of 1 minus 4.6 mu. Again here also you have to convert it in mm. So 51.46 into 10 raised to power 6 upon B is 1000 into 20 FCK into D square. I think here something is being cut. So substitute the value of D. Mute yourself.
मैम 20
Yes,
का
Sunny.
स्क्वायर आएगा ना?
20 का स्क्वायर नहीं आएगा. FCK की वैल्यू 20 है. यहाँ पे 200 का स्क्वायर आएगा. और यहाँ पे ऊपर also you have to multiply it by 10 raised to the power 6.
200 का स्क्वायर.
Yes. The depth value for depth is 200. So into 200 square. Also here also 51.46 into 10 raised to power 6. So after calculating, you are going to get the value as 775.315 mm square. So check, calculate AST required for the main reinforcement. Here multiply the moment by 10 raised to power 6 and also substitute the value for D, that is upon into 200 square. Yes, everyone had done with the AST required. Everyone had got the value, that is 775.31. Okay. Now AST minimum, that is minimum area. So 0.12% of B into capital D. So 0.12% of B, again B, the value for B is 1000 and capital D already you had calculated before. So capital D is 225. So the value you are going to get it as 270 mm square. So do AST minimum. Then after that, for calculation of spacing, you have to use 10 mm 5 bars. So using 10 mm 5 bars to up till here, then we will proceed further. Yes, done.
Yes.
Okay. So using 10 millimeter 5 bars, you have to calculate the spacing. That is pi by 4 into 10 square, as you are going to use 10 mm 5 bars. So pi by 4 into d square upon AST required, that is 775.31 into 1000. So you are going to get spacing as 101.29 mm. So after rounding off, you are going to get it as 100 mm. So provide 10 mm phi at the rate of 100 millimeter center to center. Maximum spacing should be 3D or 300 mm. So our spacing is less, so it's okay. So you have to provide 10 mm 5 bars for 100 millimeter center to center spacing. Then you need to calculate AST provided. So for calculation of AST provided, you need to calculate. Again, you are going to use 10 millimeter 5 bars. So pi by 4 into 10 square upon 100 into 1000 will be, you are going to get AST provided. So AST provided आपको मिलता है 785.4 mm square. AST provided मिलने के बाद you are going to calculate the percentage minimum. Percentage minimum you are going to calculate for you are going to calculate this for the calculation of tau c. So percentage minimum, the formula to calculate minimum percentage is AST provided upon B into D into 100. So AST provided आपने already पहले ही calculate किया है, that is 785.4 upon B. Here there should be 1000, so B is 1000 into 200 into 100. So percentage minimum मिलता है 0.39%. So solve up till here. If anyone is having any of the query, you can ask. Always you have to consider the minimum spacing. Whatever minimum value you are going to get of the spacing, that spacing you have to consider for the design. After completing, let me know so that we shall proceed for the next step. Last 1 minute is there. Those who are not given the attendance, give your attendance in the chat box and rejoin the lecture again. Once the meeting gets over, you have to rejoin it again. We will try to complete this sum by today itself.
वो कितने steps है?
Yes. Yes,
और
Tanvi.
कितने steps है?
और 3 steps है. 3 से 4 steps है.
Okay, ma'am.